Narration. Hey, so have you ever heard of the Collatz conjecture? It's a mathematical problem that dates back to the 1930s and has baffled mathematicians for decades. The question is simple. If you start with any positive integer n and then apply a very specific set of rules, will the sequence always reach 1? Sounds easy enough, right? Well, as it turns out, almost all Collatz orbits attain almost bounded values, which means there's some pretty fascinating stuff going on in this seemingly simple problem. But here's where it gets weird. Even though the vast majority of orbits reach a certain value, there are still some that don't, and we can't say exactly what that value is because the problem has not yet been solved. It's like trying to predict the weather without any scientific tools. You can make educated guesses based on patterns and trends, but there's always going to be an element of uncertainty. Let's break this down. So what does it mean for an orbit to reach a bounded value? Well, imagine if you were to roll a dice over and over again. Eventually, you would expect the numbers to even out, maybe not perfectly, but close enough that you could make predictions about future rolls based on past results. That's what we mean by bounded values. Now let's talk about the orbits themselves. Each positive integer n starts an orbit when it is subjected to the Collatz function. This rule says that if n is even, divide it by 2. If n is odd, multiply it by 3 and add 1. You then apply this rule repeatedly until you reach a single number, which in our case is 1. So why do most orbits attain almost bounded values? The answer lies in the nature of the Collatz function itself. It's kind of like a game of musical chairs where the music never stops. As long as there are enough players, eventually everyone will find a chair, even though we can't say for sure when it will happen. In conclusion, while the Collatz conjecture may seem like just another unsolved math problem, its implications reach far beyond numbers and equations. It reminds us that sometimes the simplest things can hide complexities waiting to be discovered, much like our own lives. Question: so, would you trust an AI system with your daily tasks?